So let's start, I guess. Welcome everyone again. Let's start the agenda for today. So first we are going to do a small personal introduction about ourselves and kick off the goal of this session today. We are going to introduce briefly the DevSecOps Academy, a small introduction to secrets management for Kubernetes. We'll introduce the course that you are going to get access to after this event. And we are going to do a small wrap up and Q&A after this session. And also, if you have any questions, don't hesitate to write them in the chat, and we are going to answer them. So, who you are? I'm Arapu. I'm working as a DevSecOps advocate at the DevSecOps Academy. Here, I'm creating courses, and I'm also working on the development of the DevSecOps Academy e-learning platform.
My name is Dominik Smit. I'm the CEO and from DevSecOps Academy and our consultancy company Arapu. My background is in software engineering and cybersecurity, and I've helped large organizations with their security awareness and security programs. And currently, I'm building the next generation DevSecOps skill building platform with Ion and the rest of the team to make an impact where people really learn hands-on new security skills.
Thank you, Dominik. Let's continue. So, who is DevSecOps Academy? We are a Dutch startup backed by venture capital firms. We have an online platform with browser-based hands-on labs. Our goal is to become the #1 in DevSecOps skill building, upskilling, reskilling, assessment sandboxes, and other services in DevSecOps. We have community-powered courses from experts all over the world via our fellowship program. So if you are a security expert and you want to become our fellow and create your own course on our platform, don't hesitate to contact us. We also have a multicultural team. So we also have actually some open positions. And if you are interested, you can check them out by accessing the link on the bottom right corner of this slide. We're going also to put the link in the chat, so you can access it and check the open positions. So this is the planning. Today we are going to do the kickoff, and you also, after this session, gonna get access to the course Static and Dynamic Secrets in Kubernetes. And on Thursday, 24th of June, we are going to do a wrap-up where we are going to evaluate the results, discuss the feedback, and also a small Q&A. So we would like you to finish the course till Thursday, till 4 o'clock, so then we can discuss your feedback. And also we will have a survey. Don't forget to complete it after you finish the course. So secret management in Kubernetes, as you can see that secret management is part of the DevOps flow. On our platform, we also have other courses around other topics in DevSecOps. So if you are interested in them, don't hesitate and check them out. Also, today we are not going to go too much in depth into Kubernetes and Docker. We expect that you already have some experience with them, like building, pushing, pulling Docker images or running images in Kubernetes. So here I have a small use case about what can happen if developers are not using secrets management. So for example, some developers are developing applications in a company, some web applications, and they don't have a proper secrets management system. So they save the database credentials into the Docker files, and then they push them into a private Docker registry. At some point, a hacker is able to get the credentials from the registry and pull the images. And because the developers were hard coding the secrets in the Docker file, then the attacker also is able to get the container, not the container, but the credentials from the database. And then he is able to drop the database which means that he deleted everything, all the tables in the database. And this is could be a disaster for a company if they didn't do any backups of their database. And in order to mitigate these threats in the future, developers should start using secrets management and never hard code their credentials in application code or in Docker files. So what is a secret? A secret is anything that can be used to authenticate or authorize in a system. It could be an username, password, an API key, a TLS certificate, an encryption key, or anything else that can be used to authenticate or to authorize. Also, a secret can be some confidential data like credit cards, social security numbers, or private emails. If you already have some experience with Kubernetes, you can recognize this YAML data structure, and this is how the secrets are stored in Kubernetes. The disadvantages of storing secrets in Kubernetes is that they are static, so if they change, then the administrator should also make sure that they are changing in Kubernetes as well. They are base 64 encoded, which means that there is no encryption and it's very easy to decode them. And they also do not have time to live, which means that if the secret is compromised, then it can be used for unlimited time till the password gets changed or their certificate gets changed or the API key gets changed. Secrets in HashiCorp Vault. For the course that you will be able to do after this session, we choose HashiCorp Vault as a secrets management tool. It's an open source tool with a very big community, and it's very easy to set up. The advantage of HashiCorp Vault is that it's centralized the secrets in an organization, so it's easier to manage them. It also does encryption at rest, so it means that all the data in the vault is encrypted. Also, it does encryption in transit, which means that all the data that the vault sends is encrypted by default. And also with Vault, we can do dynamic secrets. HashiCorp Vault is about like it uses RBAC, so it's role-based access control. It has inside it has roles and policies. A role is bound to a policy, and the policy specifies the access privileges. So on the right side of the slide, you can see here two policies from Vault. You can see that both of them start with a path. So Vault is everything about paths, and in the policy you should specify the path and the capabilities that are allowed for this path. So for example, this is secrets data map. It's a policy for the secrets engine, which is the static secret engine in or key value store in Vault, and it allows reading and listing the secrets there. So in case a client will use this role, with this policy, they will be able to read and list the secrets in the key value store. And the second policy is for the database backend. It's used for the dynamic secrets for databases Vault, and this policy allows reading the secrets in the portal minus read-only directory. In this session, we are not going to go too much in depth about the roles and policies, but if you are interested to learn more about them, you can check the preparation lab of the static and dynamic secrets in Kubernetes course and learn more about that. Static secrets. Here we can see a picture of the static secrets, how the workflow is of the static secrets management work in Vault. So static secrets are defined ahead of time. They are usually API keys from third-party vendors. Usually the API keys that you cannot change very often, you don't have control for that service. Also, static secret could be a Wi-Fi password, which is a password that you usually didn't change. So static secrets cannot be automatically rotated. They are hard to track their usage and do forensics because everybody is sharing the same secret, so you cannot know what machine got compromised and what secret got compromised. You just know that the static secret got compromised. And static secrets impose more risk than dynamic secrets. And here is the picture about the workflow. So in advance, the admin should create policies in Vault. Here is a policy for the DevOps user, for the apps, and for the services applications. After the admin create the policies, then the DevOps user can write the secrets into Vault. So in our case, it's an API key and a DB root certificate. And after that, then the applications, apps can request the API key from the Vault. Of course, the apps application should have a token, so it will be able to authenticate to Vault and get the secret it requires. And the same happens with services application. It also has a token, a Vault token, that it uses to get the database root certificate. Dynamic secrets. Dynamic secrets have a time to live, which means that they expire at some point, and then they cannot be used again. And it's easy to track the usage of dynamic secrets because each client has its own secret, and then we can find out where the breach happened, on what machine, or what client got compromised. Dynamic secrets are created on demand, and a dynamic secret is unique every time someone requests it. So here is how a workflow for dynamic secrets works in Vault. So the client makes a request to Vault using specific time of authentication. In Vault, you can use different time of authentication. You can use token authentication. You can use Kubernetes authentication. For example, you use that in the course. You can also do AWS, Azure, or any other types. You can just check it out. There's a lot of types of authentication. So after the client makes a request to in our case, it could be the token to Vault. Vault will check the token. If it's valid, then it will create a username and password in the database and return it back and send it back to the user. Also make a audit request into its audit logs. So in case of a breach, or if you want to check the logs, you can see what which client has what secret in its logs. Here we have the workflow of secrets management in Kubernetes with Vault. So first, the Kubernetes will deploy a pod using together with the service account token. And after that, when the application will need the secrets, it will call Vault together with the service account token that it got during deployment of the pod. After that, the Vault will check if the service account token is valid. It will call the Kubernetes API to do that. And if everything is fine, if it's a valid token, then the Vault will return back to the application Vault token, which the application will use later to request the secrets from Vault. So now we're going to look into what happens next after the application got the token. So here is a workflow of getting dynamic secrets using the Vault token. So we assume that the application already got the authentication token for Vault, and it can request now secrets. So now the application will make a request to Vault. Vault will verify the token. If the token is valid, then it will create a username and password in the MySQL database and return back the credentials to the application. And then after that, the application will be able to communicate to Vault and retrieve the data that it needs. Next, my colleague Dominik will talk about today's event and about the course that you will be able to do after this session.
Yeah, okay, thanks, Ion. Quite a complex topic, and we just briefly scratched the surface here. So let's quickly go to the platform. So this picture that you're seeing currently here in the slide should be familiar. This is the registration page in order to register on our platform and get access to the course. So let's quickly have a look. So when we go to the platform and we search for the course, then you will find here the same image as we have seen, as we have shown, sorry, in the presentation. And the first time you access it, you will see this page. So basically, this is our course information page that shows a trailer of the course. It shows some description. It shows the fellows. Ion is here as well, and mentions a few other important information regarding the course. So once you have read that, you can click on Go to Course, and then you will see the following screen. So here you'll see actually two sections. So on the left side, you see our preparation lab, and on the right side, you see the hands-on lab. So we advise you to start with the preparation lab first in order to prepare well for the hands-on lab. It is also only possible to start a hands-on lab when you have completed the preparation lab. So the preparation lab is basically the theory that Ion just talked about. There will be some more in-depth resources to read. And at the end of the preparation lab, you will have a quiz. So take this quiz in order to test if you understand the basic concepts. And once you have finished the quiz, you can start with the hands-on lab. So for this course, we have two hands-on labs. The first one is static secrets management, and the second one is dynamic secrets management. So like Ion already explained, these are two different concepts. So we also have two different labs for it. Once you choose, and it's advised that you just start with the first one, that's static secrets management, and you press on start, you see this pop-up that's coming up. And basically it will notify you that you only have 3 hours available for this lab. So there currently is no pause button, so you will have to do the lab in one attempt. And be aware that if you don't make it, or if you don't press on check results at the end of the exercises, that the lab will be automatically destroyed. So make sure that you finish the lab within one go within the 3 hours. So that's important. Okay, let's quickly go back to the presentation. Let's see. Okay.
It opened the console, I think.
Yeah. Okay, let's refresh this. Okay, so let us, now we unfortunately have to go all the way to slide. Come on. Okay. That didn't work out. Maybe we should go a little bit slower. We just had this. Okay, so hands-on lab. So like I just explained, when you start the hands-on lab, you will have 3 hours to complete for each lab. So both 3 hours for the static lab and 3 hours for the dynamic lab. So you have basically 6 hours in total. There is no pause button, so the labs need to be completed in one time. It doesn't mean that you actually need 3 hours. So some people finish it within 1 hour, some in 2, some need the full 3 hours, but you basically have a maximum of 3 hours to complete it. Like I said, after 3 hours, the lab will be automatically destroyed if there was no review requested, or if you just started it and then you went on and did something else, then the timer will start running, and after the timer runs out, the lab will be destroyed. We have a system in place that does automatic checking. So whenever you're going through the hands-on lab, it will automatically check if you're doing the right steps or the right things. You can see a screenshot here on the right. So you basically get a green check mark whenever you complete something successfully. This system is currently still in beta phase. So it might be that sometimes it doesn't recognize if you're doing the correct thing. So don't worry then about not continuing, but most of the time it can quite accurately tell if someone is doing something correctly or not. We have hints in the platform, so in the hands-on lab, sorry. So if you get stuck, please be aware that you can take hints. There will be, let's say, a maximum amount of number of hints you can take before you drop down in level. But if you get stuck, this is something that you can take in order to get unstuck. Don't worry if you're not able to make it the first time. We will be able to give you another retry. So don't worry about not being able to complete the lab. It's more important that you try, and we will be able to help you out. We have a big green support button on the right bottom of our platform. If you have any questions, please reach out to our support staff, and they will be happy to assist you. So use that button. And since this platform, we are a startup, not everything will be perfect yet. So you might find some bugs here and there. Please report them to us so we can fix them and we can improve the platform. That's that's of great help to us. At the end of the lab, there will be a survey that you can fill in that we will also be using in the next session, the wrap-up session, where we can discuss then some of the feedback that all of you gave. It will be anonymized, but this survey and the answers and the feedback that you provide will help us to improve the course and the platform. And of course, the most important of all is to have fun. We hope that you will learn something from this hands-on experience. We hope that you will learn some new concepts around secrets management in Kubernetes, so that you can basically take on and use that knowledge, in your next challenge or your next assignment that you will need to do. So that was basically our story. We have some time left now for any questions that someone has. So we will be looking into the chat to see if there are any questions.
Yeah, I forgot to mention something. On the course information page, it's written that you need a Linux system to do the lab, but now it's not anymore the case, because we have now on our platform an online IDE, and there you will get access to it, and you will be using the online IDE for the lab, so you can do the lab from any kind of system that you have. So the system doesn't matter anymore.
Yeah, because we have the online terminal.
Yeah. So it's a Linux terminal.
Yeah. Okay, let's see if there are any specific questions. Put this a little bit here, like this.
So if you have any questions, write the questions right now.
You can write them in the chat, so we are able to answer them. Someone says, please give some brief on service account. Vipul, what do you mean with that question?
Dominik, we have service account to establish communication between from our Kubernetes cluster. So I just want to understand what exactly a service account is. Yes.
So you mean you want to understand what a service account is, correct?
Yeah, exactly.
Yeah. So service accounts, right, are a concept in Kubernetes to, for example, use in this case, right, that HashiCorp Vault uses for authentication purposes. So within a service account, there are certain configuration that you can do, and I don't know the full specifics. Yeah, you have to check the preparation lab and the resources on that. But basically, it allows us to configure, okay, the containers that you're going to run in Kubernetes, you can run them with a specific service account. And then in Vault, you can basically say, okay, the containers that are running within the service account, they are allowed to get secrets from Vault. Right, that's a little bit how it works. So you use that as an authentication mechanism, where also HashiCorp Vault is able to integrate with. And then it can help you, let's say, authenticate against Vault from within your Kubernetes cluster. But
Okay,
I would advise you, if you want to learn more, about the service account specifically, then look at the Kubernetes documentation. They have quite good documentation, and I think you will find all of your questions there.
Okay, it's for authentication, and for authorization, we have RBAC, role-based access control.
Yeah. So that's the
Okay.
concept that Vault uses.
Okay, I got it. I'll go through the preparatory lab.
Yes. Okay,
Hi, Dominik. This is what. Hi, Dominik. Sorry to interrupt you there. Yeah, this is one. I have a query on the slide that mentioned the transaction of role between a pod and the vault. Can you go to that, please?
You mean this one?
Yeah, this one. Mm-hmm. Can you explain this process once, please, if you don't mind?
You want to again explain it, Ian?
So first, Kubernetes deploys a pod using the service account. So the pod will have inside the service account token.
Yeah.
And in order to make the authentication with Vault, when it will try to authenticate, it will send the service account token to Vault. And in order for Vault to check if this service account token is valid, it will also connect to the Kubernetes API. And this is why you create also a service account on the Kubernetes API, and you give you'll need to give that service account and cluster role binding to allow it to allow Vault to talk to Kubernetes in order to be able to verify if the token is valid. Does it make sense for you?
Yeah, totally. Yeah, got it. Thank you. Thanks, guys.
Thanks for the question. And then I see a question here from Suraj says, what permissions does the service account require to be able to work fine? So like Ian just mentioned, right? So the service accounts need specific, need specific access. You will also configure that in Vault. So that basically Vault, like Ian just mentioned, can contact the Kubernetes API to verify, right?
Yeah.
If the
token is valid.
If the token is valid, exactly. So you will all be doing that in the hands-on lab. So I think once you do it, then you will also understand even more how it works. So yeah, I really advise you to read on in the preparation lab and then start with the hands-on lab. And then once you're actually doing it, it will be much better understandable. It's quite difficult for us to really explain it in an easy way on the slides. But once you start doing it hands-on, it will be much more understandable.
Yeah, in the hands-on lab, you'll go through all this flow, and every step will be a step in the flow. So you want to understand it better how it works.
Yeah. So one more time, I will display the registration link for the people that missed it, or also look in the chat. So here it is again, the shortened URL. Make sure that you register. After you register, you will be able to do the course. And then we are looking forward, on Thursday to discuss the feedback and to see everyone what they thought about the course. And yeah, I hope that you all have lots of fun doing it. And if there are any other things, please reach out to our support staff, and we will be able to to help you out. So thank you very much all for joining, and I hope to see you back on Thursday.
Good luck with the labs.
Yeah, exactly.
There are 2 labs. Don't forget about this.
Yeah. Good luck. Bye bye, guys.
Thanks, guys.
Bye.
Bye. Bye. Thank you. Thank for this.